Okay, in this video I'm going to show you how to use Rcommander, which is a graphical user interface for R. And in particular, in this example, I'm going to do a repeated measures analysis variance, which is not very straightforward, but I'm going to show you how to do that. Now it starts with the data file. So let me show you the data file that I'm going to use for this example. This is a study that has, I think, like 35 participants. It's all repeated measures. Subjects took, so this is a comma delimited CSV file. And what it has is the variable names at the top. That's important. And subject identification number, the tests. So there were two tests that subjects had. They had a test where they did a simple recognition test, and they were asked, is the item old, yes or no? Or is the item new, yes or no? Yes or no. And so it's the old test or the new test. So two tests. And then we have different items here. So a hit is an old item called old. A miss is an old item called new. Correct rejection is a new item called new. False alarm is a new item called old. There's a proportion for each one of these. So all of these four here would sum to 1. The misses and the hits would sum to 1. And the correct rejections and the false alarms would sum to 1. And then there's a response time for each of these measures as well. And so we're going to do an analysis on this data set to give you a quick overview. So this is repeated measure or within subjects, and this is within subjects. Everybody completed both tests. So that's the data that we're working with. Now don't save. So now to start, what we're going to do is I'm going to use two libraries. So I'm going to use library AFX to do the analysis of variance. So what you want to do to load that is just type, this is an R console. Of course, you have to have R installed and Rcommander installed. But just type library AFX. That'll load up that package. And then we're going to use library dplyr, which is going to help us filter our data set. So I'll show you how to do that in a couple of steps as well. So then to start Rcommander, you just type library, and it's rcmdr commander, and oops, I typo there. So library rcmdr. Let's try again. That's good. And Rcommander will start. So what you have is you have an output window, and you have a script window, which will use the script window. And then, of course, you have various menus. Now, if you're doing other kinds of analysis variance between subjects, or even, I think, to some extent, some mixed models, you have all kinds of options in here to use these. You can find some other videos that sort of show you how to do that. But with repeated measures, model's not straightforward. So the analysis is a little bit more cumbersome. So I'm going to show you how to get around that by using the scripts, and you can use the scripts in R anyway. So the first thing we want to do is load our data. So we're going to go to data, import data, and it's just a CSV file. So we're going to import from text file, and this is what you're going to call your data frame. Data frame is an object in R. So we're just going to call it data1, and you'll see that we refer to it in our script. Now the field separator here is commas because it's comma delimited data file. And so you click OK, and now it's going to ask us which data file do we want, and you're going to navigate to wherever your data is stored, and I'm going to select our data file here, and I'm going to open it. Now there's two ways to view the data actually within the Rcommander. So you can click on View Dataset, and it'll pop up over here, and you can sort of see there's all the data just like we had before, nicely organized. The other thing that you can do is just type the data frame name. So data1 is the data frame name, and if you type it in our script window, if you highlight and do Control R, it'll run it. And so here's our data frame. So we know that's what's in memory. That's our data frame. We can sort of scroll through that. So those are the two ways you could do that. Now one thing I want to show you is if you do this str data1 command, if we highlight and run that, it'll tell us a little bit about our data frame. So it tells us the variables that are in our data frame. It got this from reading the Excel file that we created. So we have sub ID, test, item, proportion, and response time. So these dependent variables here are represented as numbers. That's good. Test and item are factors, which is good, but their subject identification number is not rated as a factor. What we want to do is make that a factor for our analysis. because we can put the subject identification number in the AFX package. You have to put that in because repeated measures uses or calculates subject variability. So we want to change that, and we can change all of this, and I have some commands over here sort of saved, and so I'm just going to copy and I'm going to paste in here. So, and I'll explain what this command does. So what you're telling it is data frame 1, it's an object, and so the variable within the object sub ID, you're going to change it, so this is equivalent to an equal sign in R code, as a factor. So you're going to change it to a factor in the same data frame with the same name. I have test an item here. It's not going to hurt anything. They're already factors, but we can change them as well. So we're going to highlight them and run it, and you'll see that the sub ID is now a factor. So we're now getting closer to being able to do our analysis. Now, if you remember in our data, let me show you the data set. We have several items in here. So if hits, misses, correct rejections, and false alarms. What if we don't want to analyze all 4? I mean, 2 of them are correct responses and 2 of them are errors. What if we want to filter our data set and just look at accurate responses? Well, it's actually really easy to do. You could manually change your data file. You could go in and cut all those out. That would be maddening. Instead, I'm going to have the computer cut it out, and I'm going to use this syntax here over here to the right. Now, the first time I run this, it's probably not going to work. I found that there's like a little bit of a glitchy bug here, but I'll explain it, I'll run it, and then I'll fix it for you, and I'll show you how to get around that glitch, and hopefully they'll fix it at some point in time. This works, by the way, these commands work fine when I use Jupyter Notebook to do an analysis, so I know that the commands are fine for the R kernel. It's just an Rcommander thing, I believe. So we're going to create a new data frame called data 2. And data 2 is going to be equal to the first data frame, but we're going to filter it. And we're going to filter it by item with the levels of hit and item with the levels of correct rejection. So that means it's going to keep the hits, keep the correct rejections, forget the other 2 things, and it's going to form this new data frame 2. And then I'll have data frame 2 printed out to the output window so you can see it. But as I said, the first time you run this, you do Control R, you're going to get an error. So see the error down here, it says just an error. If I go in here, what I found is if I change it to double quotes, technically either quote should work, but if you change it to double quotes, and by the way, I've done it the opposite way, it just drove me mad. You just have to do it. And then if you run it again, Control R, you'll actually get your data frame out. So this is data frame 2, and you'll notice it's the same, but it's, oh wait, that's data frame 1. I scrolled too far up. This is data frame 2. You'll notice the errors are gone, so the misses and the false alarms are filtered out of this data set. So now we're ready to do analysis on our second data frame. So I'm going to paste 2 commands here, and I'll explain these 2 commands. It's going to do simultaneously, it will do the analysis of variance and do a nice table for us with some additional information. So this is a new object, so you can call it whatever you want. I was just working with analysis of variance 3-way. This is not a 3-way ANOVA, but you can call this whatever you want. It's just called analysis of variance 3-way, and it's equal to AOV-EZ is actually part of that AFX package. It's a analysis of variance easy because it is easy. And the first entry that you have is you have your subject identification number or your whatever variable is holding your subjects in it. So that's your subject variance. So we put sub ID in there. The second entry is your dependent variable that you're analyzing. So I'm analyzing this thing called proportion. So I put prop in there, and it is case sensitive. So if you notice in the data frame, it is all capitalized, so it has to be all capitalized. Third entry here is the data frame that you're analyzing. This can mess you up. If you put data 1, it's going to do something different than data 2 because there's 2 data frames in memory right now. Then you just tell it the design. So I have 2 within subjects variables, test and item. So that's essentially your model. If you had a between subjects, there's a field to put a between or mixed model. You can put your between and within. You can identify all the variables in that one line. There's documentation. If you just search for the AFX package, there's documentation which tells you all of the details about this particular package. But that's how you would set it up and do it. Now this nice table works better in when I use a Jupyter Notebook, but what it does is it displays, so you have to display your outcome of the analysis of variance in some sort of way, and it does so. It's going to display it, and then it's going to give us the effect size. So ES stands for effect size, and PES is partial eta squared. So that's what I use, and that's what's going to be output. Then I use corrections for sphericity violations, and I use the Geyser greenhouse correction. So I can put that in there, and it'll automatically correct for Geyser greenhouse, which is awesome when you're doing analyses that involve that. So it'll automatically adjust the degrees of freedom, and it'll give you the corrected degrees of freedom, and it'll give you the corrected p-values. And then the mean square error. Now it's set to false. You just change this to true if you want the mean square error in your output table. So all I have to do is highlight these two and run it, and boom, we're going to get our analysis of variance. And here you see you have your test, your degrees of freedom, the F value, the PES, of course, is the partial eta squared, and the p-value is 0.43, so it's not significant. We do have a difference in item effects here. And we do have a marginally significant test by item interaction. So that's the interaction there. So that's your ANOVA table. Now you might be wondering, well, what if you want means? What if I want cell means? Well, you have some syntax here, and I'll explain it. I'm going to paste it in. So I'm creating this thing called A means, which your cell means. You take your second, it's your second data frame, right? And you're going to group the data frame by both the test and the item variable. So we're going to get each of the individual 4 groups, and you're going to summarize it, and we're going to create this variable called mean proportion, mean prop, and it's going to be equal to the mean of our prop variable. So that's the proportion variable. And we're going to get the standard deviation is going to be equal to the standard deviation of that proportion variable. Now I also want to know how many observations are in each cell. So we have the frequency here, which will give us the number of options in that cell. Now that'll create it. Then you have to display it by this command A means. That drove me crazy at one point in time because I was calculating it and was not displaying it and was wondering what was happening. So if that happens to you, that's a good trick. So if we highlight these and run it with Control R again, you're going to get your mean. So here's the mean for each of the test and the item levels. This is your mean proportion, standard deviation, and your frequency for each one of those. So that's it. You see how to do a repeated measures analysis of variance. You see how to filter your data and get the group means out of it. It's just that easy.